This is the basic form of the Pythagorean identity. Sine squared plus cosine squared equals 1. But what we can do with that is manipulate it to get other forms. So if I keep the sine squared on the left side, I can subtract cosine squared from both sides. And this is a new expression. Sine squared is equal to 1 minus cosine squared. So if I saw sine squared, I could replace it with this difference. If I saw this difference, I could replace it with sine squared. Go back to the original. I can do the same thing with cosine squared. I can keep it on the left side of the equation, keep my 1. When I subtract sine squared from both sides, it disappears from the left side and shows up in the right side. Now those are the two basic manipulations of the Pythagorean identity that we're most familiar with, but I'll go ahead and show you other ways you could have manipulated it. If I had wanted to, I could have kept my sine squared. I could have subtracted 1 from both sides, subtracted cosine squared from both sides, and those would be equal expressions. So you need to practice or work with those manipulations so that you can recognize them. If you know your basic, you're in good shape, but you should be able to recognize manipulations of that. Now there are two other Pythagorean identities, and they're both derived from this first one that we came up with by using the Pythagorean theorem. If I take this expression and divide everything in here by sine squared theta, as long as I'm doing the same thing to every term in here, that's perfectly okay. I know that sine squared over sine squared would just be a 1. I think we remember a while ago from our ratio identities that cosine squared over sine squared would have to be cotangent squared, because it's cosine over sine makes cotangent. So this would simply be plus cotangent squared theta. That's supposed to be a O there. And I think we all know what 1 over sine was, because we just had that over here. 1 over sine is, and I wrote that wrong, 1 over sine is cosecant theta. So this is a new Pythagorean identity. Instead of the 1 being what they're equal to, it's 1 plus cotan squared theta equals cosecant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. Now I can take that and manipulate it. I could do something like this. Say 1 is equal to cosecant squared theta minus cotangent squared theta. I could be subtracting that cotan from both sides. That would be one manipulation. Or I could keep the cotangent squared theta on the left and subtract the y from both, the 1 from both sides, and it would look like this. So those are two basic manipulations for this Pythagorean identity. And on your notes, there's places for you to write at least 3 forms of each identity. Now if I go back here and I go back to my basic Pythagorean identity, sine squared plus cosine squared theta equals 1. And this time, instead of dividing by sine squared theta, I think I'm going to divide by cosine squared theta. And we're going to do pretty much the same thing that we did a while ago. Sine over cosine gives us tangent, but that's going to be squared. Cosine over cosine is 1. 1 over cosine squared is secant squared theta. So the co's were together up here. Without a co, we're together down here. So tangent squared plus 1 equals secant squared. Or if you like this form better, you can simply switch those by the community property. 1 plus tangent squared equals secant squared theta. And then we can do the same thing we were doing previously. We can take 1, keep it on the left side, and take that tangent squared and subtract it from both sides. Or we could keep the tangent squared theta where it was and take and subtract the 1 from both sides. That would be our 3 forms of this Pythagorean identity. 1 plus tangent squared equals secant squared. Keep the 1 and subtract tan from both sides. Keep the tangent squared and subtract secant squared minus 1, not plus 1 y'all there, but minus 1. So you need to take the time to put these 3 sets of each Pythagorean identity into your notes at this point in time. And I am so sorry, when I was looking back over here, I noticed that I had miswritten this. So I hope someone noticed that I was wrong. That should have been 1 over secant theta there, not 1 over sine theta. So make sure you did not write that mistake on your notes.